Hello students, in this video we will do exercise 1.5 in which we will study about the complement of a set. Now what is complement of a set? Let U be the universal set and A is a subset of U. Then the complement of A is the set of all elements of U which are not the elements of A. Symbolically, we write it as to denote the complement of a set A with respect to set U. Now suppose universal set has the elements 1, 2, 3, 4, 5 and there is set A which has elements 2, 4. Now complement of a set that is A dash is equal to the elements which are in universal set but not in set A, and those elements are 1, 3, 5. We can also from this we can also write that A complement is equal to universal set minus set A. Now some properties of complement of a set. First one is complement laws. Now complement laws, here A union A complement will be equal to universal set and A intersection A complement will be equal to null set. Second one is De Morgan's law. According to De Morgan's law, A union B whole complement will be equal to A complement intersection B complement, and A intersection B whole complement will be equal to A complement union B complement. Now laws of double complementation. Now complement of A complement will always be equal to A. Fourth one is laws of empty set and universal set. Now complement of a null set is always equal to universal set and complement of universal set is always equal to null set. Exercise 1.5, in our first question, universal set A set B and C set are given to us. Now here I am doing 4th, 5th and 6th part in which we have to find out A union B whole complement of A complement and B minus C complement. In 4th part, we have to find out A union B whole complement. For that, first of all, we will find out the value of A union B. Now, A union B means all the elements of A and B. Now, and the common elements will be written only once. So, these will be 1, 2, 3, 4, 6 and 8. Now A union B whole complement will be the elements of universal set which are not in A union B. Now those are 5, 7 and 9. Now fifth part is we have to find out complement of A complement. Now first of all, A complement will be the elements of universal set which are not in A. And those are 5, 6, 7, 8, 9. Now A complement, whole complement will be the set of elements which are not in A complement and are present in universal set, and those are 1, 2, 3, 4. This will be equal to set A, as we have already studied that A complement whole complement is equal to set A. Now sixth part is B minus C complement. Now B minus C will be the set of elements which are in B but not in C, and those elements which are in B and not in C are 2, 5, and 8. B minus C complement will be the set of elements which are not in B minus C and are present in universal set, and those elements are 1, 3, 6, 7, and 9. Now in question 4th, universal set A set and B set are given to us. We have to prove that A union B whole complement is equal to A complement intersection B complement. Now first of all, A union B will be equal to all elements of A and B, and common element will come only once, and that is 2 here. This will be 2, 3, 4, 5, 6, 7, and 8. Now A union B whole complement will be the elements of universal set which are not in A union B, and those are 1 and 9. Now A complement will contain the elements of universal set which are not in set A, and those elements are 1, 3, 5, 7, and 9. Similarly, B complement will have the elements of universal set which are not in B, and those are 1, 4, 6, 8, 9. Now A complement intersection B complement will be the common elements of A complement and B complement. Now common elements are 1 and 9. So from first and second, we can say that A union B whole complement is equal to A complement intersection B complement. Now in question number 5th, we have to draw the Venn diagram for each of the following. Now in first part, we have to find out A union B whole complement, or we have to represent A union B whole complement in Venn diagram. Now here, suppose this rectangle denotes the universal set, and set A and set B are represented by the circle. Now here, first of all, we'll find out A union B. Now A union B will contain all the elements of A and B, including the common element, that is A union B. Now A union B whole complement, this is set A and this is set B. Now A union B whole complement will contain all the elements of universal set which are not in A and B. That means it will contain, we will set area which is not in A and B, and this will represent A union B whole complement. Now in second part, we have to represent A complement intersection B complement. Now first of all, again, if we represent the universal set by a rectangle and set A and B by the circle, we can say that first of all A complement will have all the elements of universal set except set A. That means the elements of set B will also come in this. This one is A complement. Now B complement will contain all the elements of A or universal set including the elements of A. And this will represent B complement. Now A complement intersection B complement will be the set of elements which are common in A complement and B complement. Now common shaded area in A complement and B complement is the area of universal set which doesn't include set A and B, and this will represent A complement intersection B complement. Now third one is A intersection B whole complement. Now first of all, A intersection B. Now suppose this is set A and this is set B. Now A intersection B will be the common elements of A and B. Now A intersection B complement will contain all the elements of universal set except A intersection B, and those will be, so we'll shade the whole region of the universal set except the common part of A and B, that was A intersection B. Similarly, we can find A complement union B complement. Now in question number 6, let Q be a set of all triangles in a plane. If A is a set of all triangles with at least one angle different from 60, what is A complement? Now here A is set of triangles with at least one angle different from 60. That means the opposite of it will be all angles will be of 60 degree. That means A complement will be the set of all equilateral triangles. Here A union A complement will be equal to universal set. Now complement of null set is equal to universal set, and intersection of universal set with set A will be equal to set A. Now common elements of universal set and set A will be the elements of set A. Now here A intersection A complement. Now A complement will have the elements which are not in A. So A intersection A complement will be equal to null set, because they will not have any common element. Now complement of universal set is equal to null set. Null set intersection set A will be equal to null set. Now here are some relations related to union and intersection of the sets. Now an A union B, that means cardinal number of A union B will be equal to an A, or cardinal number of A plus cardinal number of B minus cardinal number of A intersection B. Similarly, an A intersection B will be equal to an A plus n B minus n A union B. N A union B union C will be equal to n A plus n B plus n C minus n A intersection B minus n B intersection C minus n A intersection C plus n A intersection B intersection C. Now in exercise 1.6, question number 2, if x and y are two sets such that x union y is equal to 18, x has 8 elements and y has 15 elements, how many elements does A intersection Y have? The number of elements in X union Y is 18. That means n X union Y is equal to 18. Number of elements in set X is 8 and number of elements in set Y is equal to 15. We have to find out number of elements in X intersection Y, and the formula for n intersection Y will be nx plus ny minus n X union Y. That will be 8 plus 15 minus 18, 23 minus 18, and that will be equal to 5. Now in question number 3, in a group of 400 people, 250 can speak Hindi and 200 can speak English. How many people can speak both Hindi and English? Let H be the set of people who speak Hindi and E be the set of people who speak English. Now, in a group of 400 people, now there are 400 people, so we can say that N H union E is equal to 400. Now, N H, now number of peoples who can speak Hindi are 250, and N E, number of people who can speak English are 200. Now we have to find out how many people are there who can speak both Hindi and English. That means we have to find NH intersection E, and that will be NH plus NE minus NH union E. This will be 250 plus 200 minus 400. That will be equal to 50. So number of people who can speak both Hindi and English are equal to 50. Now in question number 5, if X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements, how many elements does Y have? Now here we have to find NY. So we can use the formula NX union Y equal to NX plus NY minus NX intersection Y. In sixth question, if in a group of 70 people, 35 like coffee, 25 like tea, and each person likes at least one of the two drinks, how many people like both coffee and tea? Here on taking tea for people who like tea and C for people who like coffee. Now here N T union Y is given to us. N C is 37 and T is 52, and we have to find N C intersection T. Now that means N C intersection T will be equal to NC plus NT minus N C union T. In seventh question, in a group of 65 people, 40 like cricket, 10 like both cricket and tennis, how many people like tennis only and not cricket? How many like tennis? On taking T for people who like tennis and C for people who like cricket, now total number of people in a group are 65. That means N T union C is equal to 65. Now number of people who like cricket are 40, and number of people who like tennis and cricket, both tennis and cricket, are 10. Now we have to find out the number of people who like tennis only and number of people who like tennis. Now here, first of all, we'll find out the number of people who like tennis only, that by applying the formula NT union C equal to NT plus NC minus NT intersection C. Now NT union C is given to us as 65 NT. This number of people who like tennis. We have to obtain NC, number of people who like cricket, is 40, and minus NT intersection C, number of people who like both tennis and cricket, is 10. Now this will be 65 plus equal to NT plus 30, or we can say NT equal to 65 minus 30, that equal to 35. Thus we can say that number of people who like tennis is equal to 35. Therefore number of people like tennis is equal to 35. Now we have to also find out the number of people who like tennis only and not cricket. That means number of people who like tennis only and not cricket. That means we have to find out NT minus C. Now NT is equal to NT minus C plus NT intersection C. Now NT was 35 equal to NT minus C plus NT intersection was 10. Now this will give us NT minus C equal to 25. Thus number of people who like only tennis and not cricket are equal to 25. Now these questions can also be done with the help of Venn diagram. Now here, suppose this circle represents the set of the people who like tennis, and C represents the set of the people who like cricket. Now universal set. Now there are total of 65 persons, so U equal to 65. Now first of all we will take the common element. Now T intersection C is 10. That means people who like tennis and cricket both are equal to 10. Now number of people who like cricket are 40, but as these 10 people also are included in this, so we will subtract them, and that will give us 30. That means number of people who like cricket only is equal to 30. Now number of people who like cricket are 40, but number of people among these 10 people are those who like tennis also. So number of people who like only cricket will be 40 minus 10, that equal to 30. Suppose number of people who like tennis only be X, so let number of people like tennis only be X. Now if we are taking only tennis, that means these 10 people are not included in this. So we can say that X plus 10 plus 30 will be equal to total number of people, and those are equal to 65. And this will give us X equal to 65 minus 40 equal to 25. Thus we can say that number of people who like tennis only, number of people here like tennis only is equal to 25. Now number of people like tennis will be equal to, now number of people who like tennis only are x and number of people who like tennis and cricket both are 10. So number of people who like tennis will be x plus 10, x plus 10, and x was 25 plus 10, and that will be equal to 35. Now in 8th question, in a committee 50 people speak French. On taking the number of people speak French as f, and f is given to us as 50, and 20 people speak Spanish. On taking s for Spanish, and s is equal to 20, and 10 speak both Spanish and French. That means n s intersection f is equal to 10. Now how many speak at least one of these two languages? I am doing this with the help of a Venn diagram, and this will be, suppose this is a set representing the number of people who speak French, and this S set represent the people who speak Spanish. Now n s intersection f is equal to 10. That means number of people who speak French and Spanish both is equal to 10. Now number of people who speak French is 50. Now 50 people speak French, but out of these 10 are those who speak Spanish also. So 50 minus 10 will give us the number of people who speak French only, and those will be 40. Now similarly, number of people who speak Spanish is 20, and 10 people are those who speak Spanish and French both. So on subtracting this common people from it, we will get the number of people who speak only Spanish. Now we have to find out the number of people speak at least one of these languages will be equal to sum of the people speak French and Spanish. That will be 40 plus 10 plus 10. That will give us 60. So 60 people speak at least one of these two languages. Now in other form, we can say that NF is given to us as 50, NS was 20, and NS intersection F was 10. Now we have to find out number of people who can speak at least one of the two languages, French or Spanish. That means we have to find out NF union S, and that will be NF plus NS minus NS intersection F, and that will be 50 plus 20 minus 10 equal to 60. So we can do this type of questions either by directly using the relation between union and intersection of the sets, or by using or drawing the Venn diagram. Thank you.